Hello everyone, thank you for joining today. My name is Madam and today we're going to be looking at power. So we have a few learning objectives, and that's to define power, to understand what actually affects power, and to recall the two power equation, which is power in watts is equal to ng in joules over time, or work done in joules over time. So if you're ready, let's get right into it. Okay, so let's start having a look at what power actually is. Power is nothing but the rate of transfer of energy. So let's give a more visual example of this. They have a pair of steps, right? Or rather a staircase. And I have my little stick man up here, okay? Now my little stick man wants to run up the steps here to reach to the top, okay, right here. Now, when the stick man goes up the steps, he does work against gravity. So we're looking at work done here. So let's write down our power equation. Power is equal to work done over time. Our work done here is a work done against gravity. He's going up the stairs, so he's going through a height, so gravitational potential energy here. So I can rewrite this as mgh over t. Okay, now these steps are all at the same height, but if my say my stickman goes up these steps really slowly, do you think that he's going to be developing a lot of power or very little power? Well, my stickman's going to be developing very little power, because if he goes up the steps really slowly, so let's actually do entirely, mgh over t, my t increases very greatly because he's going up so slowly. It's going to take him a long time to get up the steps, so my t is going to go up, so my power is going to decrease. But now let's imagine he runs up the stairs. Now is he going to develop a lot of power or very little power? Well, he's going to develop a lot of power. That's because now mgh it's the same set of steps, right? So we're still going up the same height. The mgh is completely the same, but now the time taken to go up those steps very little, because he's doing it so fast, and so the power developed by the stickman is very great. So that's all power really describes: the rate of energy, how fast a certain energy is transferred. If we get a lot, if we take two amounts of energy, but we transfer one over a long amount of time, so let's say a cup of water, and just slowly pouring out, you're letting it dribble out, that's not going to develop a lot of power at all. Let's say we have another cup and we just turn it upside down, we dump out all the water all at once, we release a lot of energy over a short amount of time, and so we get a lot of power developed. So that's what power is. Okay, so now let's have a look at a worked example. Now again, as always, we're going to highlight all of our keywords. So the energy transferred to the water was 1050 joules. So this is part of a bigger question, but really everything in these questions is right here. So the time taken for the water temperature to increase by 0.6 degrees, write down the equation which links energy transferred, power, and time. Okay, so we need a power equation, which is power is energy transferred over time. That's our answer right there. Now, calculate the mean power supplied by the sun to the water in a pan. So really what we're looking at here is a pan filled with water placed out in the sun, and the sun is heating up the water. So first, let's write down our power equation. Power equals energy transferred over time. Now what we want to work out is the mean power supplied. Now, we have actually got our energy right here, so that's 1050. So we don't have to worry about energy at all. But we do need time. And it's telling us the time taken for water temperature to increase by 0.6 degrees Celsius was 5 minutes. But we need our time in seconds. So first we convert 5 minutes to seconds by just multiplying by 60, because 60 seconds in a minute. That gives us 300 seconds. Now we substitute these values into our equation over here. So we do 1050 over 300, 3000, and that gives us 3.5 watts. That's our equation for a symbol for unit for power, watts. And again, it's already on the answer line here, but we write it anyway. And so that's our answer right there, 3.5 watts.